This demonstration shows how to draw a pentagon knowing the given side length as opposed to fitting it within a circle. And this only uses a straight edge, a compass, and a pencil. Now, I'll draw a pentagon here and show what it is that we're after. You have a pentagon, and that pentagon has a known side length to it. That's this. And that's repeated on all of these. So all of the angles should match all the way across here, and all of the side lengths should be the same. Now the way that this is drawn is that it's based upon a circle arc like this, that is, this is the midpoint, and that is divided into fifths all the way across. It's a very interesting process, but it does yield accurate pentagons. And this method actually will allow you to draw any polygon that you want that's a regular polygon with any number of sides by simply doing the same process. So for example, if you wanted to draw a nonagon, which is a 9-sided polygon, equilateral polygon, what you do is you draw your circle with their half circle with the radius point, and you divide this up into a total of 9 divisions, and you'll be able to draw the nonagon with the exact same process. So the first thing that I'm going to do is I'm going to draw a line which represents this bottom, or the bisection of a full circle, that right there, the diameter of the circle. So I'm going to draw from here to there and just guess at where the center point is and decide how big I want my pentagon to be. So I will say I want a side length that's this big. Now what I do is I find that center point and I draw an arc, and it can be longer than that halfway point, so it can extend a little longer if you want, but it has to at least go all the way across. Now what I'm going to do is divide this half of the arc up into fifths, which means I start, if this was 1, you'd go 2, 3, 4, 5, and 6, because that makes a segment that's 5 segments between them. So there are a few things that I can do to make an accurate guess here, and usually it takes me 2 to 3 adjustments to get this right. But my first guess is to say that if I don't change this at all, it's not a guess, but if I don't change it at all and I put a mark here and then a mark there, I'll end up with a mark exactly at the end there and make 3 divisions. That's not what I want to do. So instead I want it to be 5. So I'm going to guess at something I'm going to put this here and just sort of make a guess, and that is that's half here and there. They're equal to each other. Then this would be a 45-degree angle as a guess, and that means I've got to go less than that. And I'm going to just try that as a guess and adjust my compass accordingly to try to get that first test. So I'm bringing this down to what I think is probably about a fifth of the arc, and I'm going to test it out by making a mark. 1 mark there, and then just carry on with these marks all the way until you get to the other end, and you'll see how far off you are. That's I can see I'm already off because this line should have been across the top. 1, 2, 3, 4, and I'm off by a significant amount. Okay, now the amount that this is off, I want to subtract the compass by 1/5 of that, because that would allow me to try all these again and see how close I can get it to this tip. So I'm going to put this back again, and because it's so far off, I'm going to go and lose about a fifth in my guess. I'm going to call that about a fifth of the overage that I did. So I'm going to try this again. This time I'm going to make the arcs a little longer because I can tell them apart from the first ones. 2, 3, 4, 5. Now, like I said before, it usually takes about 3 turns to try this. On my second, I am that close, so now I'm going to squeeze this bigger by what feels like about a fifth, and I should get closer. If it took me 4, that's okay. Now, all those marks that I made are not relevant anymore, so I think in order to make things a little bit easier for me to see, I'm going to erase them a bit because they don't need to be there anymore, but they are really visible. So reduce them a bit. That's a little less visible. Okay, and now these arcs I'm going to make a little bigger so I know for sure what I'm looking at. 1, 2, 3, 4, and 5. Now that came really, really close. I'm going to go with it. So I've got these positions marked off. 1, 2, 3, 4, and then the fifth one is down there. Okay, so my first step was to draw this line across here. The second one was to get my compass adjusted to what the side length of my pentagon needs to be and draw a half circle or an arc all the way across. You can go longer if you want to, it doesn't matter. Third step is to divide this arc into fifths, which I've just done. It took me 3 tries, but I got really close. Okay, so now the next step is to skip the first point and draw a line to the second one. When I do that, I will have made the exact angle necessary to make a pentagon. So I'm going to line this up, draw that line, and I've got exactly the arc, the angle right here that makes up the shape of a pentagon. All right, so now that I've done that, all of the remaining points that I have found, I will draw a radiating line out from this center point. From the radius, I will draw a line radiating out like that, and a line radiating out like this. Now, this one is not really necessary, but you'll see why I drew it and how it relates to this problem. It is not necessary because of the way that I could use my compass. But anyway, I'm going to now set this up to reset excuse me, the compass to the dimension of the circle that I drew to begin with, because that is that's the length of my pentagon, which matches here too. So what you do is you built this one, you built that one, and so from here you cross there and you find another leg. So I'm going to carefully set the compass down, try not to let it move, get adjusted, and draw this line. You can see I'm forming a pentagon. So now I'm going to take the compass again and go to the new position, and where it intersects there, I make the last point for location where I can make my pentagon lines. So I'm going to go from this point and cross, and you'll see that they actually cross on that line. So you can see how it's possible to just not draw this line and simply put an arc there and put an arc there. So if I were to do this again, you could draw this line, find the center point, make this arc, which is based on the length of your pentagon that you want, divide this into fifths, skip the first one, draw the second one, radiate out the third one, and skip this one. Don't bother with it, because then you reset your compass to make sure that it's that radius. Find your first mark. From that mark here, you crisscross right here and there, and you find your other mark, and now I can draw the rest of the pentagon out. This mathematically works out really accurately. It makes, as depending on the precision of your drawing, it should make a perfect pentagon. And it's a perfect pentagon based upon a known side length. So if I were to erase the extraneous elements here, you'll see that what I'm ending up with is just the pentagon. That's the only important part here. So I erase all this extraneous stuff. And there's the pentagon that I'm looking for.